Okay, so now we're going to do the number of diagonals, which means we don't count the adjacent sides. Okay, so how would we think about this problem?
I think it's almost the same thing.
Okay.
But because you don't use the one you're counting with.
All right.
And you can't use the two next to it. So let's say we start here.
Okay.
You can't use these two, but you can connect up the rest.
All right.
Mm.
So you tell me how many line segments are going to be coming out of a vertex here when we're just looking at the diagonals only.
Well, it would be n. I think n minus 3.
Very good. N minus 3, because there used to be n minus 1 coming out of it,
And then we
had to get rid of this one, and we had to get rid of that one. So it's n minus 3 times.
Well, but you're not doing the edges.
Right. So a single vertex has n minus 3 coming out of it. How many vertices are there?
Well, there's n of them.
There's n of them.
So
N minus 3 times n. And that's it?
then, we have to divide. We have to divide by 2
Why?
because we were over counting.
We're over counting again. Okay? Because this one here that we've drawn in, that goes from here to here, just like before, we've counted it coming out of this vertex, and we're going to count it coming out of this
And
one.
plus, that's a Isn't that? It's the edge of it again.
No, these are the edges here. This is a diagonal. So we double counted. Okay. So how many diagonals does a pentagon have?
I think it was 5 diagonals.
Yeah, it had.
There were 5 on the inside. Does our formula say 5?
Well, 2 times 5 over 2. Yes, work.
It works. How about a 10-sided, a decagon? How many diagonals does a decagon have?
Well, 10 times 7 over 2.
There would be 35.
35. Now the challenge problem that we were working on this morning said a figure had 27 diagonals. How many sides does it have? How do we solve that problem?
Well,
27.
we can say that n minus 3 times n over 2 is 27.
Okay. Why don't you write, because I can't write sideways. N minus 3 times n over 2 is 27.
And then you can multiply by 2.
Okay, so n minus 3 times n is what?
50.
Is he writing on the screen?
Yeah, that looks okay.
Okay, so n minus 3 times n is 54. Now what are our options for solving this complicated equation?
Well, you can use 9 and 6.
Okay, that's one option. So how many sides would it have?
It would have, it would have 9 sides.
It would have 9 sides. Okay.
You could use the quadratic formula.
You could use the quadratic formula. You could multiply everything out and use the quadratic formula.
You could look at the divisors of 54 and see which ones are separated by 3.
Aha! You could look at the divisors and see which ones are separated by 3. Yeah. So that would be another way to do it. In general, you and I haven't talked about quadratic equations. In general, quadratic equations can be a little tricky to solve. But when you know you have a formula that's telling you something and you know the answer is going to be an integer, then it shouldn't be too hard to solve. You're right, you can just look at the divisors. Okay, so what are the divisors of 54?
They're 1 and 54.
1 and 54.
2 and 27.
2 and 27.
3 and 18.
3 and 18.
4 and it doesn't work. 5, nope.
6 and 9.
And 9. This is the only one that's separated by 3.
It's the only one that's separated by
But
3.
you could also use the negative integers. But we can't have
We're
negative
talking about
sides.
sides.
Yeah, we're talking about sides here.
So we can't use negative.
Yeah, we won't have negatives. All right. Good job, guys. Good job. That's an important problem in that it helps you understand a connection between geometry and counting, which is fun. And the symmetry arguments that say we have to have the same number of sides coming out of each vertex is a very powerful argument in counting.
Yeah.
All right. Good work.